all computations in bases other than 10 are performed the exact same way as those in base 10. However, when a computation is equal to or exceeds the given base, we will use mental conversions to convert from the base 10 numeral to the numeral in the desired base. So what does that mean? It's easiest to see it in action. So let's just take our first example here. We have 2 3 base 4, not 23, it's 2 3 base 4 plus 1 3 base 4. So I'm just going to take this off to the side so we can see it a little bit nicer. So 2 3 base 4 plus 1 3 base 4. Do I really need to write the 4s there? Maybe not. I can probably do it in my head, but I like to keep the 4s there so I can use it as reference material. Again, you will see. So we're just going to add like we normally do. When we add, we just add from the far right over to the left. So 3 plus 3 is 6. So we got a 6 here. But remember, we're in base 4. So once we get to 4, we have to cycle back to 0 and count back up. So 6 is 2 more than 4. So we have the remainder here of 2, and 4 can go, 4 is only just one interval of itself before 6, so we can carry a 1 over here. Because we can have one set of 4, and if we go to an 8, that would be 2 sets of 4. So we only have one set of 4 to go into 6 with a remainder of 2. So we bring the 1 over, and now we just do the math again. 1 plus 2 is 3, plus 1 is 4. So again, it goes in one time evenly with no remainder. So no remainder, and it goes in evenly one time, it's 1 extra, and then we carry the 1 there. So 2 3 base 4 plus 1 3 base 4 is 102 base 4. I know it's weird, but just take your time with it. Let's look at another example. 645 base 7 plus 324 base 7. So 645 base 7 plus 324 base 7. Could you actually write the numbers out as 7 or 4 or whatnot? Yes. But is it likely that you're going to confuse it for part of the number? Exactly. So I leave it as written out form. So again, we're going to do our math. 4 plus 5, or 5 plus 4 is 9. But 9 exceeds 7 by 2. And 7 can go into 9 one time, so 1. And then 4 plus 2 is 6, plus 1 is 7. There's no remainder, or there's no, it doesn't exceed 7 by any, excuse me. 7 doesn't exceed 7 at all, so there's nothing extra. And 7 goes into 7 one time. And then 3 plus 6 is 9, plus 1 is 10. 10 exceeds 7 by 3. And 7 can go into 10 one time. And then we have a 1 there, because we carry it down. So 645 base 7 plus 324 base 7 is 1302 base 7. So let's look at subtraction now. Subtraction, again, we handle subtraction like we normally would in our own base system. So 2, 3 base 5 minus 1, 4 base 5. So 3 minus 4, we can't do that, so because the top number is smaller than that, so we have to borrow 1. So we're going to borrow 1 from here, so 2 becomes a 1, and we're going to add to the 3, but since we're adding in our base 5 system, we're going to add 5 to 3, and that's going to give us 8. And now we're going to do 8 minus 4. 8 minus 4 is 4. It's underneath the 5, so we haven't exceeded 5, so we're good. And then 1 minus 1 is 0. So 2, 3 base 5 minus 1, 4 base 5 is 4 base 5. Now let's look at it for this one here. 475 base 8 minus 267 base 8. So 475 base 8 minus 267 base 8. So again, 5 minus 7 doesn't work because the top number is too small, so we're going to borrow 1 from 7. 7 is going to become a 6, and we're going to add 8 to 5, which will make it a 13. Again, this is just because it's in our base system, we're converting it, so we can still use it as a 13 technically. So 13 minus 7 is going to give me 6. And then I'm going to do 6 minus 6, which is 0. And then 4 minus 2, which is 2. Base 8. So 475 base 8 minus 267 base 8 is 206 base 8.